In this video, we'll be going over the Astro build log. In my last video, I kind of detailed the features and performance of the Astro handheld, and in this one, I'd like to talk about my design experience, the things that I did, the things that I tried that didn't work out, and kind of my overall design process for building this thing. No good engineering design process goes well without starting off with some design goals. First and foremost, I'm cheap. I wanted this to be cheap for me. Overall, the parts cost is pretty expensive, probably pushing about $400. But most of the components of the device were things that I already had. They were in my junk drawer. They were just sitting around not being used, and I wanted to use as many components that I already had as possible. So I actually wanted to keep the cost of the new parts that I bought under $100. I also wanted this to really have some good ergonomics. I had seen a lot of DIY handhelds that were sort of boxy and they looked like they were not very comfortable to use. Other designs that were really, really good, like the Retrolight CM4, was sort of beyond my manufacturing capability or what the amount of time that I was willing to invest in this project in terms of electronic design and expense. So I kind of wanted something that was balancing that cheapness with feeling good and something that I would really want to live with. I want to use it every day. I want to play it for a few hours a day and really have a good experience with it. And then finally, I wanted to use the Jetson Nano. And this is a because I could type of thing. I had looked around and I didn't see that anybody had used a Jetson Nano. And I'd seen some emulation videos from Tectoy Tinker and ETA Prime on using the Jetson Nano for emulation. And I thought, why not? Let's give it a try. That brought in a whole other set of challenges in terms of the size of the module, power consumption, heat dissipation, all kinds of stuff like that. So that got to be really challenging. About the same time, I started doing a lot of research. I was reading on the BitBuilt forums. I was watching gaming handheld videos from ETA Prime and Retro Game Core. And I was looking at other DIY projects, principally the Retrolight CM4 from Stoned Edge and DMCK5. And I was also looking at Ben Heck handheld console videos and all kinds of stuff like that. And really seeing how people are building these things, getting the tips and techniques and kind of figuring out what it was that I wanted and how I wanted to approach the problem. And all of these resources were really great. I'm going to link to a bunch of ones that I found super useful in the video description as well. I started out in the ergonomic design with a bunch of cardboard prototypes. So I sort of laid out, I knew how big the screen would be, and I sort of laid out basically, how big I wanted it to be in terms of size and seeing if I could fit it in there. And I started off with something, this is sort of like a switch light size that's a little bit taller. And I just sort of held it and tried to figure out where do all the buttons land. So everything just picking it up naturally, I put the buttons under where my thumbs just naturally land, and as well as the switches. And you can kind of see I'm a little bit off in most places, but because that's where things go. But the D-pad here, the action buttons there, joysticks down here, start and select. I should, if I was going to do this again, I would move all of this stuff up a little farther, particularly start and select. It's kind of a stretch to get down here, and I use it a lot because I use it for the menu system and save states and stuff like that. On the back, there's an outline of where my finger goes, and that's where I wanted to put the sort of the grip so that it feels a little bit nicer. And basically I wanted a good, I used this to figure out what the layout would be and if it would fit on my 3D printer. The next version I did was also cardboard, and it was another sort of iteration to see if the thickness would feel good. When I had it, I put the Jetson Nano in there to see if it would actually fit and what that sort of size would feel like. And also to see where the sort of hot spots would be, where the cuts would be. So with this one I used, I cut down a little bit and kind of tried to build in the taper on both sides so you kind of get a feel of how it goes and seeing where I could put the controls and joysticks. It didn't fit exactly like how I'd hoped, but this helped me sort of get the layout and get the feel of it. And again, I think that cut down on prototyping quite a bit, I could feel exactly where all of this stuff would be and get a sense for how it feels in the hand, and get through a couple of iterations in a cheap, quick format rather than 3D printing a whole thing. So once I knew the form factor of what I wanted everything to fit inside, I had to start thinking about the components that I wanted to use and how I was going to lay them out to sort of fit into this handheld device in the most efficient way possible. I really wanted it to be as small as possible. So the first thing that I did to figure out if everything would fit was model all the things that I already knew of that I could use that were in my junk drawer, or things that I could find existing 3D models for. So for example, the Switch joysticks, the Jetson Nano module itself, and I modeled the battery and the power distribution board and the fan and all of the sort of big components I modeled myself. Or found 3D models for. I was also able to find 3D models for off-the-shelf boards like the amplifier module and the HDMI to TFT board from Adafruit. And I spent a lot of time figuring out how all these components would fit together in sort of the most efficient space possible, right? Trying to get that into a sort of handheld form factor. And you can see it's pretty crammed in there. The majority of the problem was figuring out how to get the heatsink in there. And if I had replaced the heatsink or used some sort of different cooling solution, I probably could have gotten it a little bit thinner, but really not too much, because the battery is also very thick, and then there's going to be some electronics in between always anyhow. So this stack up was really useful, and then I used this stack up of the electronics and the arrangement of the electronics as a framework to build the case around. So rather than building the case and figuring out how the components would fit inside, I started with getting the components in places where I wanted them to be, and then I built the case around them, which actually worked out really well. I was going back and forth with design and electronics and sort of figuring out all these different things. I was also doing power tests, which was focused on figuring out if I could run the Jetson Nano off of the battery bank system that I had, and if I could push enough current to be able to do those high performance emulation tasks. For power, I had these 10,000 milliamp hour power banks that had outputs that could supply combined, I think, up to 4 amps total, probably more than that. The insides of them have this little manager board that one of the outputs is rated for 3 amps and the other one is rated for 1 amp. And what I ended up doing was doing some testing and seeing if I could combine them so that in parallel they both provide enough current to drive the Jetson Nano. And that ended up working out really well. I originally thought that I could talk to the microcontroller chip, the fuel gauge chip on this thing, directly using I2C, but it turns out that there's a secondary microcontroller that manages the power delivery of this management board. So I couldn't talk directly to it without sacrificing power management and stuff like that, and there wasn't a breakout on it. So it ended up being a little weird, but I was able to fit the battery and the power management board in the system, and I used the LEDs on the side of the power management board as the battery indicator through the case, which I think looks super sharp, and I'm really proud of that part. I had originally connected the battery using 1/10 of an inch headers and header pins, and it turns out those are not rated for the amount of current that this thing needs. So I had some brownout difficulties when my original testing with just the power bank had worked just fine. So I identified that by accident. I actually felt after doing a run, the connector had heated up a little bit, and I was like, oh, I'm an idiot. So watch out for that. Now they're just connected using high gauge wires inside. At this point in the development process, I was pretty familiar with Fusion 360 from years ago and in real basic designs. Usually it was 1 or 2 components or a simple mechanical design or something that was entirely meant to be 3D printed. I really ran up against my knowledge very quickly here because I was trying to design something that was more free form, that was form fitting in my hands. It was integrated with electronics and things like that. And Fusion 360 is really awesome because it is really a product design, an integrated product design. I could design the gamepad schematic. I could lay out the printed circuit board. I could then translate this printed circuit board layout into a three-dimensional model that I could include in my major design and have it included all in one thing. And then any changes that I make upstream in the schematic or the PCB layout automatically gets changed in the design as a whole, which is really, really cool. Also, all of the interaction between all of these components is really, really powerful. So for instance, let me turn off the case face. This is sort of the device without that case face on it. And you can see that, like, I modeled the D-pad, I modeled the buttons and membranes, the joysticks were already modeled, I included the PCBs, all kinds of stuff like that. And any changes that I make to those positioning, all of the holes in the case face are actually related to the position of those things. So layout and changing things is as simple as moving the objects around in the model environment, and then the rest of the design will update around them. That became super handy when I was going through iterations to design the trigger buttons and shoulder buttons on the design. I went through like 4 iterations of this, trying out different things and seeing what worked and stuff like that. And every time it was, where are the cutouts and what is the design for the buttons and stuff like that. I could design all of those things upstream and the whole cutout would change, and doing revisions on them worked out really well. Fusion 360 also has some really amazing tools for doing thermal analysis. So I was able, once I got the majority of the design constructed, I was able to set up sort of the airflow characteristics and the thermal characteristics of the Jetson Nano under load and do thermal analysis of how the system would perform under these conditions and what kind of temperature performance I could expect out of the system. And I don't think these are correct, but it gave me enough confidence that I'm not going to sort of hit the thermal limit of the Jetson Nano. So with active cooling, even this tiny little fan, which actually has pretty good airflow, it's going to be able to handle this issue no problem. And in actuality, when it's running, you can feel the heat coming off of it, but I've never hit the thermal limit running any emulator. I learned a lot of this stuff from Product Design Online YouTube channel and the Autodesk YouTube channel itself. I watched a lot of YouTube about how to integrate product design across all of these different things and looking at their workflows and what tools they use to take advantage of it. This particular design is a combination of lots of different pieces, starting with this base form that is just sort of a generic 3D model that I used in the form environment. So rather than like working from a strict design, I started with something that was about the right size, and I sort of crafted it to be something that is fit, and that was using the spline environment. And then once you sort of progress through all of those components, you can build on the mechanics of this thing piece by piece. So for instance, let me turn off a bunch of stuff. So for example, from that base form, I could make a shell, then I could start building up the different components for mounting things like the bosses for putting the case together, putting in these fan grills, mounting points, all kinds of stuff, right? And each one of these is sort of its own set of sketches and modules, and because it's all built and related together, it's really easy to integrate them and make changes later on. So I had a lot of fun doing this, learning Fusion 360 and sort of upskilling design skills and figuring out how to do all these different things and stuff like that was really, really fun. And it was really interesting to do, and I had a great time doing it. I cannot recommend Fusion 360 strongly enough. It's a really, really powerful tool. And I think if you're able to get access to it, highly recommend it. Next, I want to talk about my controller design process. Now, I wanted a layout that was pretty comfortable, that used stacked shoulder buttons, and had good responsiveness. I've been using an 8-bit DO controller that I really like, and it kind of had the Super Nintendo layout in terms of the buttons and how everything was arranged. So I went and found Super Nintendo replacement membranes that I really like. So I based the design around those, as well as the controller board design from the Retrolight CM4. What I started off with was prototyping the whole control system on a breadboard, so I know that the joysticks work, and this is really for me to get an understanding of the software and all the buttons and how everything works. I used an Arduino Leonardo that is able to behave as a human interface device, so I can make sure that everything worked in concept before I actually implemented it, and if it actually worked with like RetroArch and stuff like that, just a sort of sanity check. The next thing I did is, as I was designing the printed circuit boards, I wanted to make sure that I had the physical layout right. So as the printed circuit boards were coming together, I printed out outlines of those, as well as where the button contacts would go. So this is basically to make sure that my membranes lined up correctly with the button contacts on the board itself. And I did have to make some adjustments, so I'm really glad I did this. You can see this says Rev 3. So I went through at least 3 of these to make sure they fit in the controller and that the button configuration was right, and everything like that. Printed circuit board design that I ended up with is a single PCB that is both the left and right controller. So you can see it's both sides of the same thing connected with a FRC connector. And what's on one side is the microcontroller that is an Atmega 8U, I think, something like that, that has the USB human interface device on it. And that's one side of the board. And you can see that both sides of the board have both sets of contacts. So it's one board that you can get manufactured, and then you just flip it over for the other side. So this is the left side, the left controller with the D-pad on it that's connected to the FRC. With the face buttons on the other side, and it's just a mirror of the board. And I knew that from like most manufacturers, they're going to give you 5 copies of a board at least. So I really only need 2 of them of the same design. So it's a little bit cheaper, and everything's on there. And then I've got like menu buttons, turbo, select, and start on the other side, and then all of the electronics that support it on this side. And these are the joystick connectors. On this version of the board, I screwed up the joy connector interface, and I had to do another revision of the whole thing anyway. As well as you can see, I had the clock rewired incorrectly on this one too. So I had to do another version of that. But when it all came together, it came together really well, and I like how they feel. It's nice and clicky. I think there could be a little bit more support on the on this side, but having these sort of controller prototypes as I went through was really useful. So this is the second to last version of the controller prototype. I went through 2 others, and I was mainly focused on trying to figure out what kind of shoulder button style I wanted. I started off with them separated. They were really small and not very nice. Then I had them sort of stacked and a little bit bigger, but I ended up with a final design that is the main trigger, the L2, is a little bit bigger, and the shoulder is a little bit smaller. I think the next version of these, I want to separate these with a little bar and push this one a little bit lower, because it still doesn't, there's not enough sort of like tactile feedback on which one you're pressing, and this one doesn't stand out enough from the big one. But it's definitely playable. I've played a few games through that use both of them, and it feels pretty good. They use micro switches in these little recessed wells here. So there's a printed circuit board inside that has some 2 micro switches pressed on them, and they're sort of mouse micro switches. So they're super lightweight, a little clicky, but not bad. I like the feel of them. And there's also in the controllers these little support stubs, and what they do is when the case comes together, it supports the back of the board and makes sure that the pressing of like the D-pad and the face buttons is really, really solid. And I'm also hoping it'll help with like joystick drift and supporting that, and making sure that this board doesn't sort of take all the stresses of, me intensely gaming as hard as I can. This is the first fully printed and assembled version, and you can see I printed in black. I thought I was going to do sort of a murdered out version all the way through because that looked good in the renders, but I started switching over to white later on. This first version had little bitty stack shoulder buttons, which were okay, but they didn't really feel super good, and they used sort of a built-in spring mechanism that I thought was clever, but it didn't actually work out super well. I also, you can't see them because they all snapped off. I also had snaps in for the display along here, and those would keep the display built in. Those didn't work out either because the 3D printing orientation is this way, and it made the snaps really, really weak. So those are all gone, but most of the internals are around the same. You can see I broke off like the nubs for, I broke the nubs off for mounting the printed circuit board. So it was a lot of iteration on getting the layout and the sort of bosses correct and making sure all that layout worked out really well as the power layout and figuring out how to connect everything together and adding strength. The second to last iteration, this one, again, used stack shoulder buttons, but it made them much bigger, and they were all part of one unit, which feels pretty good. I added the USB host to it, a little logo, a power indicator to tell me if the board is on, if it shuts down correctly. And most of the layout internally is the same. I put the battery on a carrier instead, and this one I actually played for quite a while. I played through Ninja Spirit on the TurboGrafx 16. It was the first game I beat using the Astro, and this gave me a lot of insight on how the layout worked and any issues and stuff like that. I also had some, I strengthened these bosses that hold the case connector, case together, sort of fixed up everything. This one used hinged shoulder buttons, so they have a little hinge here, and they work together. The hinge pin is just another piece of 3D printer filament. These worked out pretty well. Again, they weren't big enough, so it didn't feel enough of a difference between them. And the final version has all the same features. Instead of a little window that has the LEDs for the power board, these two cases were printed in PLA, and it was kind of brittle and it would kind of snap off. I started learning to print in PETG, and I really like how tough it is. And it's a little bit more flexible than it is brittle. And it's also a little transparent, which I thought was cool. So I used the transparency to have the power LEDs come through on the bottom. So it's a straight through indicator. There's no window or anything there. And then have a little bit of black inlay. I use this white PETG, which is a little bit transparent. You can kind of see some of the components through it. Eventually I'm going to print a fully transparent case. Did a little bit of sanding on the board itself, or on the case itself. I like the color of it, so I'm not really worried about the color or texture, even though you can see like all the printing contours and stuff like that, but it feels good. I'm not going to paint it. I'll probably do a transparent version later on because I want to see I want people to see all the hard work I put on the inside. I also have a different mounting on the top, arranging the circuit boards a little bit higher and moving the joysticks in caused some space conflicts. So the mounting bosses that I had through the case in these positions had to get moved, and I ended up with the sort of edge connectors on the top. And I would do, the next version, I'm going to do one on each side as well. You can't really feel them, so I wouldn't mind having them, even though they're under my palms on these sides. The D-pad is modeled after the Super Nintendo, and I went through some iterations on that, mainly to get the rounding right. I've only painted on the inside of the little arrows. I also increased the pivot on it so that it pivots really nicely. So we've seen a lot of design. Now let's take it apart and see what's inside. So there's 5 screws holding the whole thing together. There's 2 bosses down here, and then these 3 on top. Okay. And I designed the whole thing to sort of open clamshell like this without having to do a whole lot of dismantling. And what we've got inside is this little connector here, actually connects to the Jetson Nano serial port. And that's where I use the TX line on the serial port as the indicator LED, because it turns off when the Jetson Nano finally turns off. And I didn't have to make any modifications. But here's everything. So we've got the battery, the Jetson Nano itself. We've got the cooling fan and a little 3D printed, one layer thick infill based fan grating. And we should probably make this smaller so that little bits and stuff don't get into the fan. And then we've got over here, there's an HDMI cable, flat HDMI cable from Adafruit that runs under the board and up to the display controller, which connects to the 5-inch display on the front of the case. We've got the controller boards. I won't take those apart because they're a pain to get back together. This is the audio board, and it's kind of in a weird place because I didn't plan super well for where it would go. And it's a little bit far from the headphone jack over here. If I was going to do this again, I would expand this like I/O carrier board. So the display is held in with this little bar and the I/O plate here. And the I/O plate is screwed into the case in two places. One screw down here, one screw over there, and one screw up there. And that holds the display on, as well as it's got cutouts for the display controller, the headphone jack, which I stole from a laptop, the USB host, which I also stole from a dead laptop, and that sort of carries everything with it. This is the power connector for the display board, which it just connects to USB down here. The power comes in through the high current inputs on the Jetson Nano I/O header, and then there's the power switch down here. Designing the case, I wanted the ergonomics to be really good. I knew I would be playing this thing for hours, and I wanted it to feel good in my hands and have a good layout and things like that. So the joysticks are inset a little bit, and that makes them pretty easy to access with the sort of ball of my thumb, and also hit the triggers on the top. There's a little bit of a taper to it. It's kind of hard to see on video, but the controller sort of tapers in towards the top. It's a little wider at the bottom than it is at the top, which makes it feel really good. Nice rounding on these corners because that's where sort of my palms go, and you get a good sort of fit and round there, as well as just a little bit of a thumb inset, or a sort of middle finger inset here. I would have loved it for this to be more pronounced, but the internals were so chunky I couldn't sort of cut in any farther to make that sort of swoop happen. I would have also loved to put like deeper grips on this, but again, sort of the limitations. I didn't want to make it any thicker than it already is, and I couldn't inset it because that's where the Jetson Nano is on that side. But the overall layout, I think, works out really well. I think it feels great. But I also have pretty big hands, so who knows if anybody would actually be able to work with this. So at the end of the day, I'm really happy with this thing. I think it's really awesome. I really enjoy using it. I really enjoy designing it. I think it's really fun to use. I really love that I can take something with me that'll play some really powerful games. I don't have to lug a laptop around and a controller and stuff like that. It's all one thing, and I can put it in like a zip case that I got off of Amazon and protect it and not worry about carrying a whole bunch of stuff around. And it's something that I made. I've never used or built something that I use so often, and I really like having gone through the design process and sort of experiencing and learning the things that I did to build this thing. There's a bunch of shortcomings. I would probably change, I think I'm gonna probably change the shoulder buttons again, like I talked about. Changing the fan and the cooling layout. I think I would want that to be slightly different. It's not speed controlled, and it is a little bit loud, so I think I would try and get a quieter fan that does have speed control, which should be just a drop-in replacement. I'm pretty sure I can find something for that. Probably stereo audio, I would go for that next, as well as you know, some other sort of quality of life things like volume and brightness buttons, getting brightness to work on the thing. That was one thing that I did try to get working, but I burned out one of the, I think I shorted out on accident one of the Jetson IO pins, and I got scared that I didn't want to burn out the rest of them. So I stopped pursuing that, and I'm fine with a full on brightness, but I'm sure I could get battery life, better battery life with a brightness control as well. But other than that, I think it's awesome. I think it's a really neat project. Again, it's open source, so you can find all the design files online at my GitHub and at printables for the 3D printed parts. The links for those will be in the description. And I hope that you enjoyed this and that you end up building your own or taking the design and tweaking it and building something else off of what I shared. Thank you for watching, and we'll see you next time.